Hello everyone, welcome to Olsen Cafe. Today we are going to start our first lesson on logarithm. Now, we have seen the log button on our calculator, but what it is really. So in this video, we will start from the very basic, which is what is logarithm, how it is connected to powers and index, and how can we convert between index, or some call it the exponential form, to log form. By the end of this lesson, you will be able to solve simple log equations confidently. Right, so do watch till the end. So let's get started. So why do we learn logarithm? Now, assuming I give you this simple exponential equations, all right, so from here, we all know by now what we need to do is we simply just change, all right, the number 8 to the same base, which is 2. So I can easily change the 8 to the power of 3, and I am able to find the index easily. Now, but what if I change the number 8 to 20? Are you still able to solve these equations? That is to how can we find the value of x? Now you notice it cannot be done so easily as the previous one. So this is when we will need to apply the log function to solve such question. So what is logarithm? Yeah, so this is the definition of log that you can find anywhere, but it means nothing if you do not understand its component. Yeah, so let's get to the basic. So over here, what you see, all right, there is a equation is written in exponential form, or you can call it a index form. Yeah, and also you have the equation that is written. I can rewrite this, all right, into a log form. So as long as I change this to a logarithm, all right, so this is called the log form. And do take note of the conditions, all right, of this logarithm, right? So over here, a is what we call it as a base, all right? So this base number, it must be greater than 0, and it cannot be equals to 1. So along the lessons, I will highlight this a little bit more, all right? So in these lessons, right, I'm going to practice how to convert index form to log form and vice versa. And this is the most basic skill in logarithm that everyone must know. So make sure you master this skill. So let's dive deeper into logarithm form now. All right, so over here, let's start off with something all of us are very familiar. All right, so which is 8 is equals to the power of 3. So we can actually take it as, asking the power question. That is, what power of 2 actually able to give me 8? All right, so we know the answer is equals to 3. So therefore, when I rewrite it into log form, I know that 3 will actually give me, all right, log base 2 of 8, which is what powers of 2 actually gives me 8. Now over here, if you look at this index form and the log form, right, it is important for us to be able to identify, all right, the important terms. So the first important terms that all of us must be able to identify, which is the index, and the other one that is important is to identify the base. So for the subsequent next few slides, all right, I will be emphasizing, all right, how can you actually rewrite it into the log form by knowing the base and the index. Okay, so here are some examples of how can we convert the index form, all right, into log form. So again, as mentioned, right, what you see here on the screen, right, this is an index form. So how can we convert into the log form? So what we do is we want to identify what is the base. So in this case, I know that the base is equals to 7. So what I'm going to do is when I rewrite it into log form, I will have log base 7. And then what we have is I want to find out what is the index, isn't it? So the index here is equals to 3. So therefore I know, all right, the log base 7 of 343, it is actually equals to 3. So with this, I am able to convert the index form to the log form. So I take note of the base and then I take note of the index. Yeah. Now, so let's take a look at another example. So I have 6 cubed equals to 216. So again, what is the base? The base here is equals to 6. So what power of 6 will give me 216? So based on this, right, what power of 6 will give me 216? So therefore, I identify the base, which is 6. So log base 6, all right, of 216. All right, the answer index here is equals to 3. So again, take a look at what is the base and then what is the index. So therefore, the trick here is, all right, we must always identify the base, then we look for the index, right, in the process when we want to convert index to log. So let's take a look at these two examples. Are you able to convert these two index form into log form? Give it a try. So what we need to do is we will need to identify the base and to identify the index. So over here in the first example, I know that the base it is equals to 2. So therefore, when I rewrite it as log form, I will have log base 2. All right, and the index is on the right hand side of the equation. All right, so with this, all right, I have the base and I have the index. So remember, index is always on the right hand side. Now let's take a look at the second example, see whether if you manage to get it right. So again, the base is 3, all right, and then the index is -1. So I will have log base of 3 and the index -1 should be on the right hand side of the equation. So therefore, when I put them together, I will have log base 3 or 1/3, which is equals to -1. So I have the base and I have the index. So hopefully you find this useful. Now that we have learned how to change index form to log form, all right, let's do the reverse. So that means I give you the log form. Are you able to change it to index form? So again, we are going to apply the same trick that I shared with you earlier on. That is, we identify what is the base and we look for the index. So in this case, the base is 2. So therefore, all right, I'm going to rewrite this as, all right, 2 to the power of the index -3, and this will give us 1/8. Did you manage to get it right? All right, I think so. It's easy, right? So let's look at the next example. So again, what is a base? And then I look up for the index. And when I rewrite it to index form, it is simply 3 to the power of -1, and this is equals to 1/3. So are you able to convert these two log form into index form? Yeah, it's not difficult, isn't it? So again, we look out for what is the base and what is the index. Yeah, so therefore, I know that base is 5. So 5 to the power of 4, it gives me 625. Now for the second example, so again, I know that the base is equals to 6 and the index is -2. So therefore, rewrite it into index form. This will give us 6 to the power of -2, and this is equals to 1/36. Okay, well done. This is easy, right? Let's take a look at the last few examples. So again, if I give you log base 9 of 1 equals to 0, so again, from log form, how can I rewrite it into index form? So again, I have the base, which is 9, and the index. So therefore, I rewrite it, I get 9 to the power of 0 is equals to 1. And we all know this is true, right? Based on what we have learned in laws of indices. So looking at the next example, I have log base 10 of 1000, and this is equals to 3. So basically, if I'm going to rewrite this into the index form, and we all know that it is true. So I have base is 10, and index is 3. So I rewrite this, I know that 10 to the power of 3 is equals to 1000. Now with this, it is time for me to introduce to you the special logarithm that all of you need to be very familiar with. So let's take a look at two special logarithms that all of us must be very familiar with. So let's start off with the very basic. So if I give you 2 to the power of 1 equals to 2, right? If I'm going to change it to log form, we all should know by now this can be written as log base 2 of 2, which is equals to 1. So again, all right, I look out for what is the base and what is the index. And we know that this is true, right? Now let's take a look at another scenario. So if we all know that any number to the power of 0 is equals to 1, isn't it? Based on laws of indices. So if I'm going to rewrite this into log form, so I will have log base 12 of 1, which is equals to 0. So again, I have the base and then I have the index, which is 0. Now with these two examples, I can introduce to you the two special log that you need to know, and we are going to apply them very often, all right, for the next subsequent videos. So over here, what you see here is as long as I have a base and the number is the same as the base, if I take log of the function, right, the value that I get is always equals to 1. Now, what is the second special law that all of us need to know? That means as long as any base, all right, log base of A, all right, whatever base that I have, as long as the number is a 1, so I know that the value of this log will be equals to 0. So these two special log function actually came from, all right, the two examples that I've just illustrated to you. All right, but one thing for you to take note is that, right, we need to know the condition as I mentioned at the start of the whole lessons today. So we do need to take note that, all right, whatever log function, right, we need to pay attention to the base, right? So you need to know that the base of any log function, it has to be greater than 0, and this base can never be equals to 1. So this is a very important condition that we need to pay attention to. Alright, so now that we have learned the basic, which is how to convert index form to log form, we are going to use this skill, alright, to solve simple log equations, yeah? So over here, I have a log form. So I want to solve for x. All I need to do is I just simply identify the base and the index. So I know I am able to rewrite this to 3 to the power of x is equals to 1. And we have previously learned, alright, I'm able to change the number 1, right, to the same base, right, which is 3 to the power of 0, and with this I'm able to find x is equals to 0 because since both sides have the same base. Now let's take a look at the second example. So I have log base 2 of 2 to the power of 5 is equals to x. So again, I am going to change this log form to index form. So I have the base and I have the index. So when I rewrite this into the index form, I will have 2 to the power of x, which is equals to 2 to the power of 5. Again, both sides have the same base. So therefore, I'm able to conclude that the value of x, which is equals to 5. So these two are the very simple equations that we can solve. Okay, so let's take a look at the next two examples. So again, I have log base 5 or 1 over 5 is equals to x. So again, I have base and I have the index. So I rewrite this to index form. I will get 5 to the power of x is equals to 1 over 5. So we all know from laws of indices, 1 over 5, I can simply rewrite this as 5 to the power of negative 1. And hence, I'm able to conclude x is equals to negative 1. Not difficult, isn't it? Now let's take a look at the second example. So I have this. So again, I have base and I have the index. I change it to index form. I have 7 to the power of x equals to 7 to the power of half. So which means I know that my answer for x is equals to half. Okay, so let's challenge ourselves with a little bit more complex equation. So over here, you notice that the base is no longer such an easy number. So I give you a base which involves algebra, which is 2x minus 1. But I'm going to apply the basic. So I have base to the power of index. I change it to index form. So I know that 2x minus 1 to the power of 3. And this will give me 64. And I'm able to solve this equation. So all I need to do is I just need to change 64 and rewrite it as 4 to the power of 3. And I solve a simple equation, right? And algebraic manipulation, I'm able to derive x is equals to 2.5. Now let's take a look at another example. So again, I have this, all right? So I identify the base and the index. So therefore, index form will give me 2 to the power of 4 is equals to 3x minus 5. And I solve these equations, I'm able to get x is equals to 7. So again, this can be easily done. Let's take a look at the last two equations. All right, so over here, all right, again, I'm going to apply the same thing. All right, so I have base, so x to the power of 1. This will give me 5x minus 1. So again, I solve these simple linear equations. I get x is equals to 1 3/4. Now let's take a look at the last question. Now last questions, I have it here. So which is, I have the base, which is x to the power of 2. All right, this gives me x squared equals to 5x minus 4. Now, so you notice over here in this case, I actually get a quadratic equation. So with these quadratic equations, I simply just factorize them. All right, and I solve, I will be able to get the answers x equals to 4 and x equals to 1. Now, so I will need to highlight something to you. So over here, I cannot just simply accept both answers. To give you a clue, what I have here is I will need to reject, right, the answer x is equals to 1. Right? So do you know why? So if you do know why, right, leave your answer in the comments below. All right, if you pay attention to what I have shared with you earlier on, right, you will be able to identify why we need to reject x is equals to 1. So now that we have covered the basic, right, you know what logarithms are and how to convert between exponential and log form, right? This is just the beginning. In the next video, we will explore the powerful laws of logarithm, the tools that will make simplifying and solving log much easier. So like this video if this helped you, and subscribe so you don't miss what is next. All right, so I see you in the next video, all right, where logs get even more interesting. All right, so I see you there. Bye.